Hey friends, welcome back to Python Programming with Akash. We were continuing with Python fundamentals and today we will talk about variables and assignments. Basically, a variable in Python represents named location which refers to a value. These values can be used and processed during program run. For instance, to store name and marks of a student during a program run, we need some labels to refer to these so that these are distinguished easily. Variables called symbolic variables serve the purpose. We refer them as symbolic variables because these are named variables. For example, the following statement creates a variable, namely marks of numeric type, marks equal to 70. Now let's talk about how to create a variable. Consider the last example, marks equal to 70. As you can see, we have just assigned numeric type value 70 here to an identifier name marks in this case, and Python created the variable of the type similar to the type of the value assigned. In short, after the above statement, we can say that marks is a numeric variable. In Python, to create a variable, we just need to assign its name the value of appropriate type. For example, to create variables, namely student and age, to hold student's name and age respectively, you need to write somewhat similar to student equal to Jacob, age equal to 16. Python will internally create labels referring to these values as shown below. The identifier or label student will refer to the string value Jacob and therefore becomes a string type variable. The identifier or label age will refer to the numeric value 16 and therefore becomes a numeric integer type variable. Let's take some more examples. Train number is equal to T hash 1234. This is a variable created of string type. Balance equal to 23456.75. This is a variable created of numeric floating point type. Roll number is equal to 105. This is a variable created of numeric integer type. Same way, you can create as many variables as you need for your program. Now comes a very important concept, which is variables are not storage containers in Python. If you are not new to programming, you must be having an idea of variables. But Python variables are not created in the form most other programming languages do. Most programming languages create variables as storage containers. Example, consider this. Age equal to 15, age equal to 20. Initially, value 15 is assigned to the variable age and next the value 20 is assigned to it. Let's see the concept of variable creation in other programming languages, that is, in traditional programming languages like C, C++. We will consider two statements being executed and see what happens in the memory. The two statements being taken into consideration are age equal to 15 and age equal to 20. In traditional programming languages like C, C++, a variable is a container, that is, it is a named storage location that stores a value in it. Initially, when the statement age equal to 15 gets executed, the variable age is created as a container at a memory address, say 202530, and it stores value as 15 in it. Then the statement age equal to 20 gets executed. Now, this statement will change the contents of the location where variable age is created. That is, with this statement, the location of the variable did not change, only its contents changed. Notice memory address location of variable age did not change with change in its value. The memory location remained 202530, but the value at the location changed from 15 to 20. This is how traditionally variables were created in programming languages like C, C++, Java, etc. Python's handling of variables. Python does this differently as compared to the traditional languages. Now let's see how Python handles variables. Memory has literals, values at different memory locations, and each memory location has a memory address. Let's assume that the values 14, 15, 16, 17, 18, 19, 20 are stored at memory locations 20200, 20216, 20232, 20248, 20264, 20280, 20296 respectively, so on and so forth. When you give statement age equal to 15, variable age will be created as a label pointing to the memory location where value 15 is stored. That is, as age now refers to the location 20216 that has a value 15. And when you give the statement age equal to 20, the label age will not have the same location earlier. It will now refer to value 20 which is at a different location. That is, now age will refer to location 20296 which has a value of 20 in it. So this time memory location of variable age's value is changed. Therefore, variables in Python do not have fixed locations unlike other programming languages. The location they refer to changes every time their values change. This rule is not for all types of variables though. It will become clear to you in the next chapter where we will talk about mutable and immutable types. Let's discuss about L values and R values now. Broadly, L value and R value can be thought of as L value are the expressions that can come on the left hand side of an assignment. R value are the expressions that can come on the right hand side of an assignment. Example, you can say that A equal to 20, B equal to 10. But you cannot say 20 equal to A or 10 equal to B or A star 2 equal to B. They will be listed as errors. The literals or the expressions that evaluate a value cannot come on left hand side of an assignment, hence they are R values. But variable names can come on the left hand side of an assignment, therefore they are L values. L values can come on LHS as well as RHS of an assignment. Multiple assignments. Python language is very versatile with assignments. Let's see the different ways we can use assignments in Python. First, assigning same value to multiple variables. You can assign same value to multiple variables in a single statement. Example, A equal to B equal to C equal to 10. It will assign value 10 to all three variables A, B and C. That is, all three labels A, B and C will refer to the same location with the value 10. Second, assigning multiple values to multiple variables. You can even assign multiple values to multiple variables in a single statement. Example, x, y, z equal to 10, 20, 30. It will assign the values order-wise. That is, first variable is given the first value, second variable is given the second value, and so on and so forth. That means the last statement will assign value 10 to x, 20 to y, and 30 to z. This style of assigning values is very useful and compact. For example, consider the code given below. X, y equal to 25, 50. Print xy. This will print the result as 25, 50 because x is having value 25 and y is having 50. Now, if you want to swap values of x and y, you just need to write x, y equal to y, x. Print x, y. Now the result will be 50, 25 because this time the values have been swapped and x is having a value of 50 and y is having a value of 25. There is one important thing here. While assigning values through multiple assignments, please remember that Python first evaluates the right hand side expressions and then assigns them to left hand side. Example, a, b, c equal to 5, 10, 7. B, C, A is equal to A plus 1, B plus 2, C minus 1. Print A, B, C. The statement 1 assigns 5, 10, 7 to A, B and C respectively. The statement 2 will first evaluate right hand side, that is a plus 1, b plus 2, c minus 1, which will yield 5 plus 1, 10 plus 2, 7 minus 1 equal to 6, 12, 6. Then it will make the statement by replacing the evaluated result of right hand side as b, c, a is equal to 6, 12, 6. Thus, b is equal to 6, c equal to 12 and a equal to 6. The third statement print a, b, c will print 6, 6, 12. Let's keep the below question for you now. You need to tell the output and also explain how is it being calculated. You will also find the same in the description box of the video. Post your answers in the comments and if needed, I will provide the explanation there. One more important thing. Please note that the expressions separated with commas are evaluated from left to right and assigned in the same order. Example, x equal to 10, y equal to x plus 2, x plus 5. This will evaluate to the following after evaluating expressions on right hand side of the equal to operator. Y equal to 12, 15. That is, firstly, it will assign first right hand side value to first left hand side variable, that is y equal to 12. Then it will assign second right hand side value to second left hand side variable, that is y equal to 15. So, if you print y after this statement, then y will contain a value of 15. Let's keep another question for you now. You need to tell the output and also explain how is it being calculated. You will also find the same in the description box of this video. Post your answers in the comments and if needed, I will explain the answers. Variable definition. In Python, a variable is created when you first assign a value to it. It also means that a variable is not created until some value is assigned to it. Consider the following code. Print x equal to 20, print x. When you run the above code, it will produce an error for the first statement, that is the line 1 only. Name x is not defined. The reason for the above error is implicit. As you know that a variable is not created until a value is assigned to it. So, variable x is not created and yet being printed in line 1. Printing using an uncreated or an undefined variable results into an error. Let's run this in Python and see for ourselves. I already have a file open. Print x equal to 20, print x. So it is giving me an error. Why? Because we tried to print x before creating it. So, to correct the code, we need to first assign something to x before using it in a statement. Somewhat like x equal to 0, print x equal to 20, print x. Now the code will execute without an error. No error this time. The next topic is dynamic typing. We already know that in Python, a variable is defined by assigning a value to it of a particular type such as numeric, string, etc. For instance, after the statement x equal to 10, we can say that the variable x is referring to a value of integer type. Later in our program, if we reassign a value of some other type to variable x, Python will not complain. That is, no error will be raised. Example, x equal to 10, print x equal to hello world, print x. Let's see this in Python ideally now. So, we did not get any error after assigning a different type of value to the variable x. So, you can think of a Python variable as labels associated with objects, literal values in our case here. With dynamic typing, Python makes the label refer to a new value. Following figure illustrates it. As you can see from the above figure, that variable x is first pointing to an integer value 10 and then to a string value hello world. Please note here that variable x does not have a type, but the value it points to does have a type. So you can make a variable point to a value of different type by reassigning a value of that type. Python will not raise an error. This is called dynamic typing. Caution with dynamic typing. Although Python is comfortable with changing types of a variable, but the programmer is responsible for ensuring right types for certain type of operations. For example, x equal to 10, y equal to 0. The above two statements are just assigning two values 10 and 0 to the two variables x and y respectively. Y equal to x divided by 2. This statement is legal because two integers can be used in divide operation. X equal to day. Python is comfortable with dynamic typing, so we are able to assign a different type of value to the variable x, which earlier had an integer assigned to it. Y equal to x divided by 2. This statement will result into an error. This is because x contains a string now and we are trying to do a division operation by 2 on it, which is not possible. Let us see this in Python ideally now. We can see that we are getting an error in the line 5. So the first two statements executed correctly, so did the third one, because two numbers are being divided. Then the fourth statement was also executed correctly because Python is comfortable with dynamic typing. Then the last statement, that is the line 5, which gave us an error. Why? Because we tried to divide a string which is not possible. So as a programmer, you need to ensure that variables with right type of value should be used in expressions. If you want to determine the type of a variable, that is, what type of value does it point to, you can use type function in the following manner. Type, then in round brackets we mention the name of the variable. Let's head to Python ideally and check how this works. We are getting the type as int because the variable a was assigned a value of integer 10, thus making the type of variable a as integer. Now I am assigning a value of 20.5 to the same variable a. Now that a has a float value assigned to it, thus its type is float, as we can see in the output. Now I am assigning a string value. A has a string value assigned to it, therefore its type is string now, as mentioned in the class str in the output. Note: dynamic typing is different from static typing. In static typing, a data type is attached with the variable when it is first defined and is fixed. That is, data type of a variable cannot be changed in static typing, whereas there is no such restriction in dynamic typing. Programming languages like C, C++ support static typing. We use type object name function to determine the type of an object. Object can be a variable or a literal, etc. With this, we have come to the end of the video. I know what you guys are thinking. Thank God it's over. Haha. I know that it was a long one with more of the theory part. Anyways, I hope that you would have been able to understand everything that we discussed in this video. If you have any doubts, do let me know in the comment section of the video. I will surely come back to clear them. Lastly, I would want you to like this video and click the subscribe button to my channel. I will be back with more learning. Until then, cheers and have a great day.